Okay, so in this example, we would like to find the Laplace transform of this function given here as the product of t cube with e to the power minus 5t. So we have two functions, one is t cube, another is the exponential function composed with minus 5t, let's say, and then we have the product between that. And then our goal is to find the Laplace transform of this. And then here we are just trying to use the table of Laplace transform, compare with one of the similar function, and then use with the help of that when I figure out the Laplace transform of this given one. Okay, so if you look into the table of Laplace transform, you should be able to figure out one of the function given there as e to the power at times f of t. So this is kind of the product of the exponent e to the power at with some function of t, right? So if we have that, let's say the Laplace transform of this is actually whatever is the Laplace transform of this function. Let's say that is if the Laplace transform of the f of t is represented by capital, let's say f of s, right? So if this is the Laplace transform of that, then the Laplace transform of e to the power et times f of t should be just the translate that to the a unit, so something like s minus a. So or let's say you evaluate this function at s minus a. So that's the kind of formula we have given, or the Laplace transform property, right? So but let's try to see how can we use this one over here to figure out the Laplace transform of t cube times e to the power minus 5t. All right, so first of all, we can see that we can actually rewrite this. If we want to exactly compare with the function given over here, we could write down this product as e to the power minus 5t times t cube, right? So we can do that. So now if we do that, we can immediately compare and then say here, okay, here is exponential, and the power we have at over here, here is minus 5t. So if that is the case, we get the value of the a is negative 5 here, right? So we get that one, and then f of t over here, that is small f of t is actually t cube, right? So that's what we have. So if we wanna, like, okay, we understand how to compare this one, and then if that is the case, to properly use this formula, first of all, it looks like we need to find the Laplace transform of only of that function first. Okay, first let's find that. So then why don't we find the Laplace transform of t cube? So what is the Laplace transform of t cube? So there is a formula also. If you look into the Laplace transform of the t to the power n given, if you look into it on the table of Laplace transform, the Laplace transform of t to the power n is given as what is that one? N factorial divided by s to the power n plus 1, right? So that's what we have given, and we can just compare with that one with this one. So t cube compare with t to the power n, so we get the value of the n is 3. So if that is the case, we get the Laplace transform of only t cube is 3 factorial divided by s to the power 3 plus 1. So 3 factorial is what? 3 times 2 times 1, so 6 divided by s to the power 4. So this is just the Laplace transform of t cube. So okay, so we have not figured out the Laplace transform of given function. We have just figured out the Laplace transform of t cube here. But now to figure out the Laplace transform of this, which should be our goal here, right? So let's try to do that. So the Laplace transform of the given function here, which is e to the power minus 5t times t cube, is actually has to be whatever is the Laplace transform of t cube, evaluate that at, let's say it's a s minus a, right? Or let's say just translate to a unit. So over here is a is negative 5, right? If you compare with that one over here, negative 5, so you just need to translate that to the a units or negative 5 units. So how do you do that? So this is your kind of f of s, right? So that is the Laplace transform of this. So over here is s. So why don't you, so if you assume that f of s is actually is equal to what is that one, 6 over s to the power 4, then f of s, so we need to evaluate what is that one. So by this formula, s minus n minus a is negative 5, so we need to compute s of negative 5. So that means s of f of s plus 5. So that's what we need to evaluate. So this should be equal to 6 over, so how do you evaluate this function at s plus 5? Just replace s completely by s plus 5, right? So this is how we should do, and then that's it. That should be our Laplace transform of the given function. So 6 over s plus 5 to the power 4. Okay, so let's try to revisit again because there are a couple of elements over here. Okay, I'm gonna okay, over here let's see again. So our goal is to figure out the Laplace transform of t cube times e to the power minus 5t. So I just try to rearrange here just to compare directly with that one, and then we did that. And then when we compare, we figure out there this f of t that is on the table of Laplace transform, that function is actually t cube over here. So by this formula it says that, let's just first figure out the Laplace transform of t cube, which we have figured out over here, right? And then this formula says that just translate that to the -5 units, so which we can do here by 6 over, just translate means like yes, replace that by s minus a -5. So we have just done that, and then this should be our Laplace transform. Okay, why don't we try another similar example and then make sure that we get this one. Okay, so how to apply. All right, so let's try to say, let's say that our goal is to figure out the Laplace transform of let's say t square e to the power minus 3t. So if our goal is to figure that out, then what do? First of all, figure out the Laplace transform of, let's say, t square, right? So which is what is that one? The Laplace transform of t square is 2 factorial over s to the power cube, so that means 2 over s cube. So that should be the Laplace transform of t square. So if that is the case, Laplace transform of this given function should be, just translate this to the -3 units, so which means 2 over, replace s by s minus -3, so that means s plus 3 to the power cube. Okay, or let's say our goal is to figure out the Laplace transform of t to the power 4 e to the power 5t. Then just figure out the Laplace transform of t to the power 4. Laplace transform of t to the power 4 is 4 factorial over s to the power 5, so which is 4 factorial. 4 factorial means 4 times 3 times 2 times 1, so 4 times 3 is 12, 12 times 2 is what, 24, so we get 24 over s to the power 5, right? So that is the Laplace transform of t to the power 4, and then translate that to the 5 units, so that means 24 over s minus 5 units. So right, so 5 then to the power, so what do we have here, 5, so just copy that. Okay, all right, I hope that you get it, how to apply this this kind of, let's say, the Laplace transform formula to figure out the Laplace transform of this similar function. And thank you very much for watching this video.